Welcome to this 11th video in which we try to find the derivative of y equals sine x. We want to know the derivative of that. Y equals cosine x. We want to know the derivative. And guess what? Y equals tan x. We want to know the derivative of that. Okay, well, let's have a look at the graph of y equals sine x. What does the derivative tell you? It always tells you the gradient of the function at any point you wish. So if I look at the gradient of the tangent here, if you think about it, sine x is a periodic function. Therefore, the gradient must show periodic behavior as well. Look at it, it's going up and down, up and down. Okay. What's the value of the gradient here? It's 0. So I'm going to graph that value there. What's the value of the... What's the next time the gradient is 0? It's now 0. So the value of the derivative is 0 here. And so on. At this point, the tangent is horizontal, so the gradient is 0 here as well. And if I look at when the gradient is at its steepest in the positive sense, if you look closely here, it's getting steeper, 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 then it starts to get less steep. It's steeper right here at x equals 0. In fact, it's 1 there. Similarly, it's most steep here in the negative sense there at pi. And with a bit of imagination, you may see a periodic graph there. Do you recognize it? Of course you do. It's cosine x. This is not a proof, it's just an observation. Proving it is a bit more complicated, but for today's purposes, we're just going to use this as a statement. The derivative of sine x is cosine x. What about the derivative of cosine x? Well, you probably guessed it has something to do with sine x. In fact, it's minus sine x, but we're going to prove that one as follows. Think of the unit circle. Here I've got the angle alpha measured from the positive x-axis. Remember, this red dimension is sine alpha, the blue dimension is cosine alpha. Now I'm going to take that angle alpha from 90 degrees. GeoGebra's called it beta, but beta equals alpha. So this point here, E dashed, makes an angle from the positive real axis of 90 degrees minus alpha. So if I put that there, yeah. So this angle here is 90 degrees minus alpha. Now look at these two triangles. They both have hypotenuse 1 because it's the unit circle. They both have the same angle here, 26.5, and they both have a right angle. So these two triangles are congruent. Therefore, all the sides and angles are equal. So if we look at this angle here, from the positive real axis, its sine is the y coordinate, the blue one. That's the same as this. So the sine of this angle is the cosine of this one. And also this is the horizontal dimension. That's the cosine of this angle. That's equal to the sine of this one. When you put those two together, you get these identities. Okay, let's see them in a bit more detail. Okay, so sine 90 minus alpha is cosine alpha, and cosine 90 minus alpha is sine alpha. Okay, so this is our task. If y is cosine x, then the derivative is minus sine x. We're going to prove that basically. Well, if y is cosine x, what I've shown with unit circle is cosine x is sine pi over 2 minus x. So now I can differentiate it because I know two things. I know the derivative of sine, which is cosine pi over 2 minus x, and I also know the chain rule. The chain rule tells me to multiply by the derivative of the inside, which is minus 1. Look at the identity here. Cosine 90 minus equals sine. Therefore, this simplifies to minus sine x. So that's our next result. The derivative of cosine x is minus sine x. Okay. So now we get on to the most fascinating one, the derivative of tan. Well, we've seen the graph of tan, its periodic function. The period is pi. And how would you describe the gradient of this function? Well, if I draw a tangent, whoops, if I draw a tangent, think about the slope of that tangent. It's always, if I start here, it's always positive. It's always going up. And if you look here, there is an asymptote at minus pi over 2. It's very, very steep. And then it's getting shallower, shallower until there. And then it gets steep again in the positive sense. So the gradient function is always positive, very big numbers. It comes down to a minimum here, and then it gets steeper again. With a bit of imagination, this is the shape of the gradient function. Now we're going to find the equation of that function. Okay, so that black function there is the gradient function. We want to know what's the equation of that. In other words, if y is tan x, therefore dy over dx, well, what is it? Well, thankfully, we know that tan x is sine x over cosine x, and that's a quotient, so we can use our old friend, the quotient rule. And that tells us we have cosine squared x on the denominator, then cosine x, you copy and paste it there, multiplied by the derivative of sine. Well, we know that. It's cosine x. Minus, then we leave sine by itself, and we multiply by the derivative of cosine, which is minus sine. Minus sine, that means I can change this to a plus. Look at the top of that fraction. It's cosine squared x plus sine squared x over cosine squared x. And that's our old friend, the Pythagorean identity. sine squared plus cosine squared is 1. 1 over cosine squared x. In higher level, they call that sec squared x. And that's the derivative of tan. The derivative is 1 over cosine squared x. Okay, so in this video we've revised a little bit of trigonometry, and we've also revised product rule, no, not the product rule, quotient rule and chain rule a little bit, and we'll pick up these themes again in the next video. And it's a beautiful sunny day today. This is the view from my classroom, and hope you found that useful.